Okay, before we talk about nonlinear systems, let's remind ourselves about linear systems. Remember graphically that a solution to a linear system of equations was where the two lines intersect. Okay, and that it gave us three possibilities. You could have the possibility that the two lines don't intersect, meaning they're parallel lines and there'd be no solution. You could have the scenario, the more common scenario, where your two lines intersect in one spot. Okay. So it would be one solution. Or you could have the case where it's actually the same line, and in that case you would have infinitely many solutions. Okay. So those were the three possibilities for a linear system of equations, a linear equation versus a linear equation. Remember, so zero solutions, no solutions. One solution, or infinitely many solutions. Okay. Now that infinitely many happens because it's the exact same line. However, if you're not graphing, if your two equations aren't the same type of equation, if they're not the same type of function, that's never going to happen. So in our first nonlinear system, we have linear versus quadratic. Okay. So this one also has three possibilities. However, one of them is not infinite solutions, because a linear equation and a quadratic equation are never going to be the same graph. So the first scenario is you could have zero solutions. Okay. Well, how could you have zero solutions with a quadratic and a linear equation? Okay. Remember, the graph of a quadratic is a parabola. It's this U shape. And I'm going to scoot that up a little bit. How could you have a U-shaped graph and a line that don't cross? Okay. Well, it's possible they just miss each other. Okay. If your parabola is up there, but your line is down here, they're never going to cross. Okay. So that's the first type that could happen. You could have no solution. You could also have one solution. Okay. How could you have a parabola and a line that only cross once? Okay. Well, they would cross at a special point. Okay. So if we have a parabola, your graph could, the linear equation could touch the graph in one spot. For example, it could touch where the vertex would be. Okay. So it doesn't cross the graph, it just barely touches it. Okay. That point's it's a special point. In math, it's called a tangent. When a line just touches the graph in one spot. Okay. So that's possible. Okay. And that tangent line doesn't have to be the vertex. It could be, you could have one up here, okay, where it just barely touches the graph. Okay. So it doesn't always have to be the vertex. Okay. And then you could have two solutions as well. If you have a U-shaped graph and a line, well, your line could cross that graph twice. Okay. So you could have two solutions. Okay. Right. So these are the ones we're going to be working with a lot. You got two solutions, two crosses, one solution, or you have no solutions. We're actually not going to solve these next ones, but I wanted to bring it up just because, Algebra 1 is linear, quadratic, and exponential equations. So you could have a system with a linear and exponential equation as well. A lot of times you compare growths with a linear versus an exponential model. Remember what the exponential graph looks like? It's a one-directional curve. We'll draw a couple of these. All right, and you get the same three possibilities as you do with the quadratic versus linear. You could have no solutions. In this case, again, the two lines just miss each other. You could have one solution. Same thing as the other one. It's just going to barely touch the graph. One solution. You could have, well, there's actually two possibilities for this. You could have it barely touched the graph in a tangent line, like so. You could also have just a horizontal line. Okay, just a horizontal line would only cross once. Okay. So you could have one solution, and then you could have two solutions. Okay. In the two solution scenario, again, it's just going to cross, it'll cross twice. Okay. That would be two solutions. Oops. All right, and then the last one. The last one is a quadratic versus a quadratic. Okay, so you notice there's four graphs on this one. A quadratic versus a quadratic has four possibilities. Okay, just like the linear versus a linear versus a linear, they could be the same line. Same thing with a quadratic and a quadratic. You could potentially have the same parabola in both equations. Okay. So we'll start with zero solutions on a linear. Okay. So our options are going to be 0, 1, two solutions, or infinitely. Okay. All right, well, zero solutions on a parabola. Well, if you have one parabola up here, opening up, and your second parabola is down here, opening down, those are never going to cross. Okay. How could you have one solution? All right, well, if you have one solution, there's a couple possibilities. You could have one opening up, one opening down, and they share the same vertex. Or you could have them on the same, their vertexes have the same y value, and they have the same a value. So it's possible to have this as well. Okay. So those are only going to cross once. Okay. Two solutions. How do you have two solutions? Well, if you have a parabola, and another parabola opening down, that one crosses twice. This one was once. And then the last scenario, like I said, if you have a parabola, and the second parabola is the exact same, that would be infinite. So it's possible that, maybe one's written in vertex form, one's written in standard form, and then you graph it and it's the same line. Okay, that's a possibility as well. All right, so that's the graphical representation of it. We're going to deal with, we already did linear systems months ago. We're going to deal with the linear versus quadratic and quadratic versus quadratic. So we're going to do a couple of different methods, just like we had with linear. We had substitution, we had elimination, and we had graphing. We're going to go through the same process with the nonlinear systems as well.